Assalamu alaikum and a very good morning to all. Today we are going to start with the compound ions. Yesterday we assigned oxidation states and oxidation number to some compound which were in the molecular form. Today we are going to study about such example which exist in the ionic form. By ionic form we mean that they may be positively charged or they may be charged negatively. So a compound ion, what is a compound ions? These are the ions which are made up of different atoms. You can see the nitrate ion, it is made up of nitrogen and 3 oxygen atom. If you talk about the sulfate ion, this is made up of sulfur and 4 oxygen atom. Like sulfur and oxygen, they are different atoms. So compound ion are the ions with 2 or more different atoms. Today we are going to take out the oxidation number of these compound ions. We have studied some rules for assigning the oxidation states and numbers. You can see we studied some oxidation number rules. The very first was whenever the atoms are in the uncombined elemental form, so the oxidation number is 0. Or if the similar atoms are combined in the molecular form, in the diatomic or polyatomic form, again the oxidation number is what? That is 0. Then we started some famous elements of group 1 and we assign they have some fixed oxidation number. Like group 1 will have +1, group 2 will have +2, fluorine will have always -1, halogen family will have -1, hydrogen is +1, but in case of metal hydrides, as you can see, this is a metal and this is a hydride. In this case the sodium is +1, hydrogen will be -1 to neutralize this compound. Oxygen is always -2, not always, but in peroxide oxidation number, that is -1. In case of this compound F2O, the oxidation number, that is +2. So it varies from -2, +2 to -1. Then we discuss oxidation number of some element which exists in a monoatomic ionic form, that will be always the same as the charge. You can see chlorine, that will be -1. For aluminum, that will be what? That will be +3. Now the sum of oxidation number in a compound, that is what? That is 0. The whole compound, the sum of the oxidation number, that will be what? 0. Whereas the sum of the oxidation number in the anion, that will be equal to the charge on an anion. So in case of, like, if we take an example, we will study today this, we will be dealing this point in detail today. The sum of the oxidation numbers in an ion is equal to the charge on the ion. Today we are going to take out the oxidation number for such compound ion which are charged in nature. Now the very first example which they have given, that is the nitrate ion. That is what? The nitrate ion. In this, the charge on the ion compound ion, that is negative. That is what? So the total charge on this compound ion, that is what? -1. That is -1. Let me first take out a highlighter. Okay, so the total charge is how much? That is -1. That is how much? -1. Now we're going to find out the oxidation number for nitrogen and oxygen separately. Let's have a look. I don't know what is the oxidation number for the nitrogen, but I do know the oxidation number for one oxygen, that is how much? That is -2. That is how much? -2. So what I will do, I will put -2 over here. And how many oxygen I have? I have 3 oxygen atom. So I'm going to multiply that with what? With 3. I'm going to multiply that with 3. So 3 2s are 6, -6 is equal to -1. Over here what I have? Nitrogen. I don't know for the nitrogen. I don't know for the what? Nitrogen. It will be like this. Now what I will do, nitrogen, to find out for the nitrogen, -6 is equal to -1, is equal to -1. Now to find for the nitrogen, what I will do, I will shift this -6 to the other side. So it will be like this: nitrogen -1 plus 6. Now to do this math, now it will be equal to +5. So this gives us an idea, okay, the oxidation number or a state on the nitrogen in this compound ion, that is what? That is +5, that is +5. So this is how we sort out the oxidation number for a compound ion. This was according to the rule number 5, which we studied in the previous slide. The sum of the oxidation numbers in an ion is equal to the charge on the ion. If we talk about SO4 -2, so the charge on this compound ion, that will be -2, that will be what? -2. And oxygen, you already know that is for single oxygen atom, that is -2. So for the 4 it will be -8, that will be what? That will be minus. So you can find out for the sulfur. This is a kind of your homework. This I'm giving you as a homework. You are going to supposed to submit this in a word form. Now the next, okay, yesterday I gave you a homework to you, so you were supposed to do A, C and E. Today you're going to do B, D. Okay, D was also your homework, yesterday's homework. So today you're going to do B and F, and you're going to submit this in the word form to me. Now we are supposed to start with the redox and oxidation number. This is a new topic in the redox reaction. Now keep this thing in mind, okay, we are studying basically oxidation and reduction in terms of oxidation number changes, how oxidation number that change while if there is oxidation happening or if there is reduction. So whenever there is oxidation, we used to say that there is an increase in the oxidation number. If I give you an example, let's have a look. Okay, I have an iron. This iron is in the +2 state. This is in the +2 state. What happened? Okay, it loses one electron. It loses one electron. So what happened? Okay, the charge that changed on the iron, and now the iron is not in a +2 state, but that is in a +3 state. So you can see iron +2 is changed into iron +3 by the loss of one electron. So in this case, you can see +2 is changed to +3. Change to +3. So there is there is an increase in the oxidation number. There is what? There is an increase in the oxidation number from +2 to +3. But in terms of loss of electron, you can say okay, in this iron, from this iron atom 2 electrons are lost, and from this iron 3 electrons are lost in total. Now this is what we call oxidation. This is what we call oxidation. Now we're going to study about reduction. What they are saying in terms of oxidation number, there is a decrease in the oxidation number. If we give an example, let's suppose we have iron. We have an iron, and that is what? That is iron in a +2 state. But what it do? It gains one electron. It gains, so you have to write gain over here. It gains one electron. So when it gained that electron, iron is now no more in a +2 state, but now it is in a +1 state. Now it is in a +1 state. So a reduction is what? That is a decrease in oxidation. So from +2 it moves and it decreases to +1. So reduction is a decrease in the oxidation number. It's a decrease in the oxidation number. You have to memorize these definitions. Now we will study another example of redox reaction, which is between a copper and a silver nitrate. You can see over here we have a silver in the form of silver nitrate, and a copper is in the metallic form. So what it will do, let's write a reaction. We have a copper, and this react with the silver nitrate, NO3, fine, and it changes to what? It changes to copper, NO3, copper nitrate. How many? 2, and plus we will get silver in the atomic state. Okay, now you can see over here in this reaction, copper was, the oxidation number was 0. That was what? 0. Silver over here, that was in a +1 state, and nitrate was in the -1 state. Now here silver in the product form, it changes to 0. Copper over here is in the +2 state. For 1 nitrate, you know, okay, what is the charge on this compound? -1. So on 2, how many? -2 you will have. You will have -2. So what they are saying, okay, the copper that reacts with silver nitrate to form what? Silver and copper +2 nitrate. This is called copper 2 nitrate. This is just representing what? The oxidation number on the copper. Now oxidation number of each copper atom has increased, of each copper, that is increased by what? By 2. But the oxidation number of each silver you can see, that is what? That is decreases by 1. That has decreased by 1. From 1 to it moved to 0. In oxidation number concept, it decreases from 1 to 0, but in other terminologies we can say okay, there is a gain of electron by the silver atom from what? From the copper. Okay, now over here what they have written, okay, let me highlight this for you. A silver nitrate, this is silver nitrate that reacts with what? With the copper, and it form what? Copper nitrate. Here the copper is in which state? +2 state, which you can see over here. Okay, and silver is formed in the atomic form. This can be called as a redox reaction because silver nitrate is reduced and copper is oxidized. Copper has lost electron. This copper has what? Lost electron. How many electrons are lost? 2 electrons are lost, and they are given to what? To the silver. So silver over here, silver nitrate as a whole is what? That is reduced. Let me change the highlighter pen. Okay, now this is another example in which we have a tin. This is abbreviated as SN. This react with nitric acid. This is your nitric acid. The oxidation number of each atom in a tin of tin and nitrogen change. Okay, over here you can see the oxidation number on tin is what? That is 0. That is what? 0. On nitric acid, here oxygen, if I don't know, let's suppose if I don't know okay, what are the oxidation number on each atom in this nitric acid, so let's first calculate this thing, HNO3. Okay, this is a compound. This is not an compound ion. Oxygen on a single oxygen -2. So on 3 oxygen, how many? -6. For hydrogen, I know okay, that is how much? +1. Okay, so this is for oxygen. Okay, so in the middle what I have a nitrogen. For nitrogen I don't know, so this will be your nitrogen and this is your hydrogen. So what? This is also plus, this is also plus. -6 + 1, this will give rise to 5, and here I have nitrogen also, and this is equal to what? 0. So when you will move this -5 to this side, so what you will get? Nitrogen is equal to 5. So oxidation number on nitrogen, that is what? That is 5. That is what? 5. It changes to a tin oxide and nitrogen dioxide, and water molecule is produced. Now on single oxygen -2, so on 2 will be how much? -4. So on 10 you will have how much? +4 to neutralize, because +4 -4 will cancel in 0. Now I don't know for the nitrogen, so on 1 NO2, on 1 oxygen -2, so on 2 oxygen -4. So on nitrogen you will have a +4. Now this is what will leave. We are concerned just with the change of the lead to the lead oxide. So each tin atom has increase in oxidation number by +4, like from 0 to +4. There is an increase in oxidation number. Tin has been, but it is oxidized, like it has lost the electron. Each nitrogen atom has decreased in oxidation number by -1. Here nitrogen was in +5 and it is decreased to +4 by 1 unit, by 1 unit. Okay, so nitrogen has been reduced. You can see here 5 electron was lost by the nitrogen, and here 4 electrons are lost by the nitrogen. So this means nitrogen has been reduced. The oxidation number of each oxygen atom is unchanged at -2. Here -2, and here you are also having -2. Same is over here. So if you compare nitric acid with this tin oxide or with the nitrogen dioxide for the oxygen, for both of them it will be same unchanged. The oxidation number of each hydrogen atom is unchanged at +1. The same happens for the hydrogen here was +1, and here it is also +1. You can see oxygen here -2. So for one hydrogen it is +1, and for 2 it is what, +2, and here hydrogen is also in the +1 state, so it is unchanged. Oxygen and hydrogen are neither oxidized nor reduced. So hydrogen here and what else, hydrogen, oxygen, they are neither oxidized and nor they are reduced. Okay, now we have to study about the concept of oxidizing agent and reducing agent. Okay, now for this we are going to study in detail what are oxidizing agents and what are reducing agents. We will be studying this in the upcoming new lecture.